Hello everyone, I am Pablo Linares with HDI Global, and our today technical video is going to be related to elastomerics. On this specific picture you're going to see two different type of assemblies. This is for the 412, this one is for the 407. When we start getting into the video, we're going to start talking more in detail on the 412. Again, if you have any issues related to any other model, please write down on the comments, and we will try to help you on your specific model. But for this specific video, we're going to start referring only for the 412. Another thing that came across in the past is that customer asking me if this is some kind of new technology on the elastomeric, and it is not. Elastomeric being there for many years. Matter of fact, on the very old helicopter like a Huey, even the 204, you're going to have isolation mounts, and those isolation mounts are also elastomeric. And also we're going to give you some vibration issues related to the elastomeric. So again, this is not something design or new technology. Is being used in the helicopter for many years. So I hope you enjoy the video, and let's start right away. Before we go into type of inspection, how to inspect it, and any other details on the elastomerics, I'd like to explain one of the effect or characteristic of the elastomeric. And even though hysteresis is something that you're going to see in metals and rubber, it's very good to discuss a little bit about hysteresis. Hysteresis, if I want to try to put in a chart, let's do this for a moment. We're going to have the vertical axis is going to be the stress, and the strain or force is going to be the horizontal indication. Now, because this is related to elastomerics, I don't have one here to explain you in detail this, but let's think about one of the elastomerics on the Bell 412 main rotor, which is the damper set. The damper set are the ones going to be absorbing and controlling the leak lag of the main rotor blades. So anytime a blade is lagging or leading, you're putting stress or forces or strain on the rubber. So every time from neutral or from static, we pull this one. This is an example, bungee cord. Every time we pull it, it's like the blade is lagging or leading. Okay, either of this situation, which happens constantly when you're flying, is going to be exposed here. If you go to the chart, like this line here, where we're going to have stress this way, and strain this way and strain this way. If you look at it, there's a curve here where even though you're putting a lot of forces on it, the stress is not that much until you get kind of on this point where the more strain you put on it, more stress it is. Of course, this range of the elastomeric is designed by the engineering in lower and Bell helicopter combined. Now, every time the blade after being lagging is moving forward, we're going to have that bungee cord or the rubber on the elastomeric going back to neutral, to static, or unloading with nothing on it. And we can say that this is pretty much the chart when happened this effect. Now, right here, if you look at it, we're going to have what we call a hysteresis loop, which is a loop completed, a closed circuit, that happening when the blade is lagging, going back, lagging. So every single time this is going on, this is happening. One thing that doesn't show here in the chart is that this stress caused by the strain is going to be changed with time and with temperature. So when you're doing this leak lag effect, you're going to have this area here, and this area that you're sitting here is equal to the energy stored per unit volume as pulling the rubber and let it go. So this is going on, that loop is going on all the time, leak lag. Of course, we're going to have other elastomeric for the pitch, and another one for the spindle bearing where you install the damper set. Now you might ask, why are you explaining all this, Pablo? I'm no engineer or anything. Because every single time you're doing this hysteresis loop, one thing very interesting happening on the rubber, they get hot. And this is very important. If you receive a helicopter and the pilot report, you're going to have a vibration. And my advice, first check everything. We're going to see that in a moment. But one thing, if you think everything is fine and you need to install the vibrating equipment, it could be a Chadwick, it could be a BXP, even BSVMS, whatever you have in there. And when you call the pilot and you want to start collecting data, my advice is let the helicopter run for a short time in order to heat up the rubber. You have to remember, depending where your operation is, could be Alaska, could be UAE, Latin America, anywhere, the rubber is going to behave differently depending on the temperature. But when you run the helicopter and the rubber get hot, pretty much is going to help you to standardize the process for troubleshooting and track and balance process. So this is why I like to explain this before we move on the training. Now the first one we're going to talk about will going to be this rubber here. This elastomeric bearing is called the pivot bearing. This pivot bearing is very interesting because this have two functions. This is the spindle, and the spindle on the end here is the main rotor blade. Now on the 412, each blade is about 118 pounds, 120 pounds, and with this helicopter running 100%, that blade, due to the centrifugal forces putting a tension on this, is about 30,000 pounds. They are designed for 90,000 pounds, so it lasts long. You have to remember that every single elastomeric, when you clean them, you cannot use solvent. You cannot use PD680. You cannot use mineral spirit. Only neutral soap and water. Nothing else. You have to be careful. If you look at the books, and if you start using solvent, they're going to be a scrap. And this is a very expensive one. Now, I was explaining you that when the blade's turning at 324, the centrifugal forces exercising on this rubber give you the tension. On top of that one, when the pilot moves collective or cyclic, the spindle is going to move up and down. That causing torsion or twisting of this. And that's the only one. So this one, it's absorbing or have effect for two different forces, tension and torsion. Does it sound familiar? TT? So really, we can say that this is the TT strap on the 412. So this is a very interesting point I want to make. The pivot bearing, when you look at it, it's going to have some lines. This line that run parallel to the circumference of the elastomeric are chimps, and these are pretty much thin metal plate. And if you want to see this blew it up, let me give you this next slide so you can see a better picture of this. In here, this line are going to be showing in here. If you look at it, this shims line metal part pieces. In between them, you see that black? That is rubber. So rubber is the key element on every single elastomeric. And that is why when we do an inspection, we're going to be seeing different type of damages and how we inspect it. Now, in the next few slides, you're going to hear me saying that you can, by the book, use a feeler gauge. When you start putting a feeler gauge here for see the lamination, the feeler gauge is 5,000. And you have to remember that feeler gauge, look, it can be like a knife. You start pushing in, you can start cutting the rubber, so you're causing more problem than solution. That's what I'm going to show you later. My advice, how to inspect elastomeric. So this will be the first line, and we're going to start talking later about different issues and how to inspect it. Before we move forward, I'd like to explain you or show you that the diameter on one section of the elastomeric here, this is smaller diameter than this. So when you inspect this and you pull collective and whole spindle moving, you're going to see that this side moves move more than this one. So this line that we're going to start talking later, the mold line, they're going to move in an angle. So this is, you're going to see that later in a short video I have for you guys. In here, The next set of line we're going to have is called the mold line. Mold line, the word mold mean is the molding device that a lord use when they manufacture or they injecting rubber into the sample to make elastomeric bearing. And this line in a way is where you're going to start purging the rubber out of this the product, the elastomeric, okay? But this line, we're going to be using it for something else. And that is my key advice for you guys. Now, if you count these lines, you're going to see that I believe they are 17. So if we have 360 degrees divided by 17, it come out with 21 and 17 degrees. For the sake of this training, let's run it up to 22. Or if you want 22, that's fine too. So that means that from one line to another, we're going to have 21 degrees. Let's put it 21 degrees for this sake. Okay, now we're going to start looking at issues of the elastomeric. This particular one here, if I can, I don't want to block you guys. This exhibit two different type of mode of degradation. The first one, this one is this rubber crumb here. It means that the rubber between those two chimps, it coming in pieces. It's already broken in pieces coming out. And it would be one of the issue. The next one, it would be that the coloring. You see that coloring there? Because this rubber is not inside anymore. Now you're going to have two chimps touching each other, causing what? Freezing. And of course, corrosion. So when you have this kind of issue, you read the books, they're going to tell you to measure accordance to the books. And you're going to hear me later and a few times that measuring this is almost impractical, almost impossible to measure this on the 412. For instance, this is a good picture, already kind of exposed to you, but if you have it in here, how are you going to measure if the damage is inside? You can see it, but how are you going to measure it? You have a very small windows for the pivot bearing to inspect it with a feeler gauge. Here on the back, that's it. There's not very much room to inspect it with feeler gauge. So when we go into that point, I like to explain a little bit better how I advise and I teach in my classes. On this particular case, you're going to have another degradation. And this one, you're going to have a chart on the book. This is called extrusion. Now, before we move forward, you have to ask yourself, who in your company does the daily inspection? Many companies and some people like to train and make other jump mechanics or helper to start doing inspection on the helicopter. Now, one of the things you need to train your jump mechanic or your apprentices is anytime you see these extrusions, it's going to look like this, like a little string of rubber coming out. You are not going to rip it off. This needs to be measured and count how many degrees. And already we come up with 21 degrees from one line to another. So here we're going to have what? 42 degrees. So this is the way on Bell Helicopter 412 chart you're going to show you for extrusion, and I'm going to explain you in a moment a little bit how I advise to use the degrees for inspecting this elastomerics. Now remember this, these are the mold lines, and we're going to be using these mold lines when we're going to inspect the elastomeric or the pivot bearing using the chart. Talking about extrusion, the one I showed you earlier, you're going to have the depth, how long are the extrusion of rubber and how many degrees. And always I like to advise the 2 point where drastically the elastomeric is degraded. It would be right here. This point here and that point in there. I'm going to talk about this later. Let's talk about this, which is the extrusion right here. It tells me that when you have about 300,000 long rubber and about 90 degrees is when the rubber, if you continue, is going to be way degraded. You see the narrower it's come back because you got longer, it's going to be failing really. So if the helicopter come back to you and you have a vibration report on the helicopter, you check the thrust plate, check the main rotor, everything is tight, sound tight, and you're going to start checking the elastomeric. And you start seeing the string of rubber coming out, the extrusion, trying to see how long is the extrusion of the rubber. If you have it more than 100 degrees, so I mean it's about 5. It's about 5 line of this. We say 21 degree one. So if you got 5, it's kind of right on the ballpark number of 100 degrees. And that could be the problem for your vibration, because now remember, if the rubber is not inside, they are not working properly when doing their jobs. So this will be one of the problems. Now, the next one, the lamination. The lamination, excuse me for a moment, let me go back and show you here what I'm talking about. The lamination, if you see here, the rubber between the chims, that is when you start seeing like a gap, and you might start seeing kind of darker color where you will be able to install a feeler gauge to see the depth. Now look at the chart. This point is called discard. Discard, remember the rule of discard is the point where you don't have to do too many measurements, you scrap the part. In this particular case, anywhere that I can introduce a feeler gauge 900,000 of an inch, I don't even care how many degrees, it's already gone. But this is going to be very impossible. As I already explained you, it's very hard to inspect this. Here come again. Here's my point. My point here that when the elastomeric start getting pretty bad here, it's going to be about, again, 80 and 90 degrees. So if I see a dark line here, that's the lamination. If I count these ones, it can help you. But again, it's very difficult. There's another way you can do it that really can help you even better, which is you have to use an hydraulic mule. And for this particular case, if you have a 412, they're going to be based remotely, and you're going to start doing 25, 50, 100 hours, maybe 300 hours, you should have hydraulic mule on site. You have to remember, hydraulic mule is required or will make your job easier if you have a mule for troubleshooting autopilot and also to inspect the elastomerics. Okay, we're going to see a few videos to show this. Now, if you look at the Bell 412 books, it's going to tell you to use the feeler gauge 5,000 size. I'm seeing customers that they got the feeler gauge and they cut it like an arrow, like a very chip, trying to shove it in the lamination to see how deep it is. And I've seen the feeler gauge or wrinkle or damage. You have to remember, this is on the load. Even if you remove it, it will be also very difficult to use a feeler gauge. And remember, because it's very thin, you can cut the rubber. So be careful how much force you put on it if you want to measure the depth of the lamination. This is one of the things that I like to show you with the help of the hydraulic mule. We can inspect the elastomeric, and this is something that we're going to be using with the help of a hydraulic mule. So this is what I was telling you earlier. Hydraulic mule really is a tool on the 412. You should have it on base. On this video, you can see the elastomerics, how the mold line, they move alongside, but you don't see any separation or step. And I've already told you the sizes in one extreme and another are not the same. You don't see them moving equally. They're moving in an angle, but they are kind of lined up one after another. And they tell you that is in good shape. Okay? Oh, sorry. Now, this is what I was telling you. The inner layer, they form more, but the change is gradual for more layers on the next. And this is another picture you can see. Remember the sizes. So this will move a little bit less than this one. That's why you see the angle. Okay, and having a straight line, it tells you that it's okay. On this particular case, there is a damage, and so with the help of the hydraulic mule, how can we look at this and have a better picture of the problem? Let me just put the video here, I'm going to show you when the flashlight move into the elastomeric. I'm going to stop the video and hopefully you can have a better picture of this. Now, in here, if you look at it here, right here, you see the mold line is cut off and then it can like step moving here. But also look at the color. So in this particular case, this is called a spindle bearing. Everybody call it spindle bearing. You look at the book, it's called damper bearing. And it's kind of funny because everybody calls it spindle bearing because this bearing is bonded into the spindle. You're never going to see this part by itself. Always with the spindle bearing, with the spindle. If you see a spindle bearing by itself, it's because it's damaged. So that's why everyone calls this the spindle bearing. Now, here's a good sample of what I was telling you on the pivot bearing. Same thing. When you see the mold line cut off like this, you count how many mold lines are cut off, and that tell you from here to here. On the pivot bearing is 21 degrees. Here is not that important because it measures differently. I'm going to explain that in a moment. Now, these brakes, you see it here, on this bearing, what you have to do, you have to try with a flashlight, check around on the front side and also on the back of the elastomeric and looking for a full separation. It means by Bell helicopter, if you go to the books, here is going to tell you the instruction. And one of the things it tells you, this bearing is scrap when you got a full delamination on both sides. It means kind of this can come off. This can come off. So either one can come off. That's one of the things you have to be checking it out. And of course, this bearing are not allowed to be replaced on the field. This has to be sent to lower. Remember, when you send it to lower, there's a bulletin in which you need to emphasize why you send it to lower, for overhaul or only for elastomeric replacement. If you have a brand new 412 and you never have this kind of operation, my advice is your company should buy one of these and keep it in spare, or make a deal with another company in case it go bad. You can have one on stock. Why? This can take as far as 4 months to replace this. I hope by today or when you see this video, this has been corrected and take less time to replace elastomeric bearing. The next one, the one I give you an example, the leg lag, this is called the damper set. And we're going to have two, one on the top, on the bottom. This is the spindle, pitch horn. This is the pitch horn, the spindle, and the damper set. The damper set are there to control the leg lag of the head. At the time I worked on 412 in the 1990s, early 80s, this damper set were replaced per side. I mean, if this is the red blade, only you replace the blade, the red blade, the upper and bottom. And they found out an issue with this. Why? Hysteresis, remember? The first time I tell you, if you replace one side and the opposite side have 1,000 hours and you put two new, what do you think happened with the leg lag? Because you have a newer rubber, the resistance for leg lag will be minimal, so the opposite blade, it will move more, causing you the symmetry of lift, mixture of vibration. That's why Bell put a rule on this, and even nowadays when you buy damper set, it comes in a set of 4. I don't want to explain details of how to do it. It should be another video, but I'm telling you that every time you're going to replace a damper set on the 412, even one is bad, this is a red blade, you're going to replace both on the red and also the opposite blade, which is the blue blade. Okay, and here we don't have anything that give you indication like the mold line. There's no mold lines. Also, you're going to be using a feeler gauge. And one thing that Bell called for it, finger to try to peel. Even Lord told you this. What happened is, if I put my finger here, the rubber go over the metal. This is aluminum and this is aluminum plate. Those two aluminum plates are vulcanized together with rubber in between. And the idea is, you're going to see the next slide, where Bell is going to tell you, you're going to put a feeler gauge between these two, and you're going to have a dimension this way and a dimension that way. Depending which is how much it is, you scrap it. My question, can you do this in the field? Very difficult. Not only because the location you're going to have an upper and lower bridge is because they are pinched. They have 85,000 in shims. And here's what happened. How can you install a filler gauge which is very hard to reach into it, and also it's under pressure, preloaded with shims? So this is impossible. Now, how did I do this one? We're going to be doing, well, this is the box. I tell you you're going to measure this way. Also, always with a filler gauge. If I can put a filler gauge anywhere like this, 1 inch, it's already gone. Anytime that I have 5,000 filler gauge and I mark it 3/4 of an inch, 750,000, you have to go all the way down. But I tell you guys, to do this on the helicopter on the 412 is almost impossible. Now, how do you do that on the field? Now, imagine this is your helicopter, and you're going to get in the cabin, and you're going to pull the rotor brake, and you can put the blade anywhere you want it. You're going to get a guide on a ladder, and you're going to get on the tip of the blade. And what you do with the rotor brake on it, you're going to move it back and forth. Back and forth. When you're doing back and forth, you're doing the effect of what? Lead lag. Here are the elastomerics. Now, if you look at it, this part here is the bottom part. The upper part, this one, you don't see it. Even on the bottom part, the bottom bridge, you don't see this one neither. Tell me how you're going to install or put a filler gauge in there. So what you do, when you're doing this lead lag, you're going to try to put your finger, be careful, you can pinch it. You can even look first, because what you're looking for is this effect. You're going to be seeing the plate. It could be the upper or the lower, whichever is the bonded. Okay. Of course, this kind of a failure is going to give you vibrations. So what you do, again, every time a 412 comes with a report of vibration, like I used to say when I work on a 212 or teach a 212 or any other helicopter, yeah, in a 212 you might run with a Chadwick to do track and balance. On the 412 you run with your toolbox. You need to inspect a lot of stuff before even thinking to fly the helicopter for check for track and balance. And one of the issues are going to be rubber. And this is the best way to inspect the damper set. I hope that this video will help you better understanding the principle of elastomerics and how to inspect it. If you like this video, please share it to your friends, and also make a comment down there on YouTube if you want more video and related to what do you like to have more video be made. I hope you enjoy it again. Thank you very much. Pablo Linares with HTI Global. Have a great day.